See, now we'll discuss one more type of problem. See, given it's a T-shaped object and all the dimensions are given, how to find the position of center of mass? Think how you're going to solve this. You know only the dimensions. Again, use the same method. Already we solved one problem. Use the same method. See, I'll say its origin 0, 0. I'll divide the center object into different objects, like this horizontal sheet and this is a vertical sheet. In this horizontal sheet, where is the position of center of mass? See, along x-axis it will be at 4 meter. And along y-axis, okay, if I say this is O, along y-axis it is 1 meter. 4, 1. I know x1, y1 is equals to 4, 1. Similarly, find the position of center of mass for this vertical portion from origin, which is x2, y2. See, x2 is 4 only. 4, how to find the y2? See, from here to here it is 2 meter and this whole thing is 6 meter. Position of center of mass for this vertical portion is 3 meter along y-axis. 3 plus this 2, I'll get 5 meter. So this is important. 5 meter, why it is 5 meter? For this portion it is 3 meter and we are calculating from this O. 3 plus 2, 5 meter. x2 is 4 and y2 is 5 meter. Now I know x1, y1, x2, y2. I need position of center of mass of this entire system. So this is 4, 5 meter. Somewhere here there will be a position of center of mass. You know the formula for the position of center of mass. XCM is equal to m1x1 plus m2x2 by m1 plus m2. And similarly, YCM is equal to m1y1 plus m2y2 by total mass, which is m1 plus m2. Means first I have to find the values of m1 and m2. How to find the value of m1? Again, use the same method. You can find the area. So let rho be the mass per area, m by area. Okay, for the first portion, for the horizontal portion, m1 is equals to rho into a1. What is a1? 2 into 8. So remember, area of this portion 2 into 8, length into breadth. So which is, okay, 2 into 8, 16 rho. Similarly, find m2. What is m2? m2 for this vertical portion. m2 is equals to rho into 2 into 6. So which is 12 rho. Now I have m1, m2, x1, y1, x2 and y2. Just substitute the values in this formula, xcm and ycm. So xcm is equal to m1, what is m1 here? 16 rho into x1, x1 is 4, plus m2 into x2, m2 12 rho into x2 is 4, whole divided by m1 plus m2, 16 rho plus 12 rho. Take rho common, I can just cancel rho everywhere. So XCM will be 64 plus 12 fours are 48 divided by 28. So you will get again 4 meter. Check the calculations. Similarly, YCM. See, YCM is equal to M1Y1 plus M2Y2 by M1 plus M2. M1 is 16 row, substitute all the values, into Y1. What is Y1? 1 plus M2, 12 row, into Y2 is 5 by total mass 28 row. So you can cancel row everywhere. YCM is equal to 16 plus 60, 76 by 28, which is equal to 2.71 meter. Here XCM is 4 meter and YCM is 2.71 meter. Position of the center of mass of this entire object is 4 meter, 2.71 meter. So it's XCM, YCM.